Hello and welcome to today's lesson. Our lesson for today is the mechanics of materials, which is one of the major branches of engineering. Our focus today will be introducing what the mechanics of materials is and what you really need to know before you can even start this course. So, depending on where you are, the mechanics of materials has different names. In some countries, it is called strength of materials. In countries like Russia, it is called technical mechanics. Or, shortly put, in their language, it is called СОПРОТИВЛЕНИЕ МАТЕРИАЛОВ. So basically, these are some of the names that are used to refer to the mechanics of materials, but they basically refer to one and the same thing. It can be called the strength of materials, it can be called technichiská mechanika. It is also called, normally for short, it is called in Russian СОПРОМАТ. What do you need to know before you can start learning the mechanics of materials? Well, the major prerequisite that you need to have is that you're supposed to be familiar with the concept of engineering mechanics. In Russian, it is called теоретическая механика, which is a direct translation to theoretical mechanics. The main thing that you need to know under engineering mechanics is statics. So basically, you need to have statics before you start looking at the mechanics of materials. You need to have a background of statics. Well, let us give a brief background of what we did in statics. In statics, we usually deal with rigid bodies. What this means is that these bodies do not undergo any sort of deformation. When we talk of deformation, we're simply talking of the change in size or shape of an object or of a solid body once a certain load has been applied to it. So when we talk of things that we deal with in statics, we are saying these are rigid bodies. They do not undergo any deformation. No matter the amount of force or load that you apply to them, they remain as they are. This is theoretical because in actual sense, when a force is applied to an object, it undergoes some sort of deformation. There's a change in shape, there's a change in size, or some sort of, change in the way it is. So basically, when we're talking of things in statics, we're talking of objects in theory, objects that do not exist. This was in order for us to understand the concepts of statics. We assume that all objects that we deal with, or all solid bodies that we're dealing with, are rigid. So when we talk of solid bodies, we're basically referring to things like rods, bars, or beams. In this course, we'll mainly focus on beams. I'll give a definition of what a beam is later on. So, for statics, we used to deal with 2D problems. When we talk of 2D problems, we're talking of problems that only involve 2 dimensions. Maybe we've been given the width and the length without being given the thickness. So for 2D problems, we use two equations for solving 2D problems. So basically for 2D problems, we said the first assumption that we are making is that for these rigid bodies, the first assumption that we made was that the sum of all the forces at a given point within this solid object is equal to 0. So the sum of all these forces that are acting at a certain point within our body, within this rigid body, is equal to 0. The second assumption is that the sum of the moments at that particular point within a rigid body is also equal to 0. So these are the equations of equilibrium that we used to use in statics. So these two are giving us equations of equilibrium, meaning the forces at a certain point cancel themselves out and give us a result of 0 if we add them. These are the two equations of equilibrium that we used to use in statics. If you see here, if you've noticed, I've written the x, y, and z axis. So these basically just tell us that it doesn't matter the axis that we are looking at, the sum of the moments, the sum of the forces along that axis, along that specific axis, is always equal to 0. Therefore, this is what we used to do in statics. When we talk of the mechanics of materials, we're now looking at something more practical. Like I've said, in statics, we used to look at undeformable bodies, rigid bodies that do not undergo any sort of deformation. But then, when we talk of mechanics of materials, in mechanics of materials, we'll be dealing with actual things that are in nature. We know that we do not have these rigid bodies in nature. We have things like steel, we have things like iron. When you apply force to these things, they undergo deformation. So basically in mechanics of materials, this is what we'll be dealing with. Now, to give a definition of what mechanics of materials, I'll be abbreviating mechanics of materials with MAM, which is mechanics of materials, or sometimes strength of materials. In Russian, it is abbreviated as СОПРОМАТ. In Russian, it is abbreviated as СОПРОМАТ. So basically, when we talk of mechanics of materials, we are saying this is a branch of applied mechanics that deals with the behavior of solid bodies to various types of loading and stress. So our main focus in mechanics of materials will be looking at how solid bodies react once a certain stress or a certain load has been applied to them. How will they change? What causes these changes? Basically, this is what we'll be dealing with in СОПРОМАТ. СОПРОМАT is a very СОПРОМАT, that is Russian. Mechanics of materials is a very practical subject. We look at actual things. We'll be dealing with steel, we'll be dealing with iron, we'll be dealing with wood, and so many other construction elements. So this is what we'll be doing in mechanics of materials. How does mechanics of materials help us? Well, an understanding of this course is very essential to the safe design of all types of structures. Like I have said, we're looking at the behavior of solid bodies to various types of loading. So we need, for us to design structures that are safe and reliable, we need to have an understanding of this course. The basic principle or the basic objective of this course is to mainly determine the stress, the strains, the deformations or displacements in structures and their components due to the loads acting on them. So I'll later give a definition of each of these terms that I've used: stress, strains, and deformations. Well, I've already given a definition of deformation, and then these others, as we go on, we will come to understand what these mean. But for now, we keep in mind that the main focus here is we'll be looking at how various types of objects or solid bodies react to various types of loading and stress. In short, in summary, we can say we'll be looking at how objects or solid bodies are affected by forces that are applied to them. Mostly, we're looking at external forces that are applied to them, how these external forces affect these solid bodies. So basically, this has been an introduction for the course. I hope you'll be with us during the next lesson. Thank you.